Hello class, so we are already finished with the DC analysis of a diode circuit. So we are going to start now with the first application of diode, which is the rectifier. So if you are going to recall the definition of a rectifier from your module, a rectifier is actually a diode circuit that converts an AC voltage into a pulsating DC. Okay, so where do we usually see a rectifier circuit? We normally see it in a DC power supply. So let me just give you a background of the different blocks that we see in a DC power supply. Okay, so the first block would be, let me just draw them first. Okay, our input, of course, is the 220 volts AC, which is 60 hertz, okay, frequency. So, ang first stage would be the transformer. That's the first block. And then the second block is the rectifier circuit. And then we have a filter after that. And then of course we have the voltage regulator. And then we have an output which is already a DC voltage. So that is actually the different blocks. So let me just explain. So, as I have mentioned, ang first stage natin is transformer. Maybe you have already encountered transformer. Okay? So, ano ba yung transformer? There are actually two types of transformer. One is a step-down transformer, and the other one is a step-up transformer. For a DC power supply, we normally use DC power supply for electronics. We normally use the step-down transformer. And there are several types of step-down transformer. Meron yung tinatawag natin na, of course, yung single output lang. Okay. Single output. So, normally, we have, ang output niya is, of course, yung terminal na 0. And then, we have, so, kunyari, 12 volts yung ating transformer sa 12 volts. Okay? And then, the second one, we have the center top transformer. Okay? So, dito, tatlo yung makikita mong terminal dun sa output, which is kung 12 din yung output natin, so it will be 12, and then we have a 0, and then 12 volts. Okay? And then the third type is we have the multi-tap. So as the name implies, okay, multi-tap transformers, multi means several, okay? So there are actually several outputs. So what is common in the market is we have ang output nito is, of course, meron tayong terminal 0 as the common terminal, and then ang output niya is 3 volts, then we have the 4.5, and then we have the 6 volts, the 9 volts, and we have a 12 volts. So, eto yung 3 types of transformer. They are step down because from 220 volts AC, it will actually be stepped down to a lower voltage. Okay? So, dito, ang ating waveform ng AC voltage is that of a sinusoidal. Okay? So, ang sinusoidal, syempre meron siyang amplitude, may frequency, okay? And then may phase. Okay? So, those are the characteristic, okay, of an AC voltage. we're going to describe it. So, we are going to describe it by its amplitude, meaning the height, okay, the height ng ating wave from here hanggang doon, from 0 to the peak, okay, peak point ng ating waveform. Okay, merong positive at saka negative. Okay, so ang transformer natin, ang output din niya, although lower in voltage, lower in amplitude, still AC. Okay, this AC voltage, let's say for example 12 volts yan, when it will pass through a rectifier circuit, then that AC will actually be converted to a pulsating DC. Bakit siya pulsating? Okay? Kasi technically, dito sa output ng rectifier circuit, meron ka pa rin makikitang parang ripples. Okay? So we have, let's say if it is a half-wave rectifier, then we have ganyan yung waveform. Okay? Ng ating half-wave rectifier. So, kung full wave naman dyan, so it looks like this. Okay? So, ganyan. So, this is your half-wave and this is your full-wave rectifier. So, ideally, pag sinabi natin DC voltage at i-drawing natin, actually it's not a waveform, but we are to represent it. It is actually a line. Okay? So, let's say for example, if it is a 12 volts DC, okay, ang ibig sabihin lang nito is 12 volts all throughout the time, all the time, okay? So, unlike of course yung AC natin na iba-iba yung ating value at a given time. So, let's just say for example, dito ay syempre, kunyari 10 volts, and then meron tayong peak na let's say 120 volts. Okay, at that particular point, iba rin ulit yung voltage niya, 'di ba? So ganyan yung characteristic ng AC. So dito, hindi pa siya straight line. So how do we make it an ideal DC power supply? Then yun yung purpose nitong filter. The filter will actually smoothen yung ating DC output from the rectifier. So, normally, may makikita ko pa rin naman na konting ripple na lang dyan. Okay. Yan, mga ganyan. And then, ang purpose naman ng voltage regulator is to fix, okay, yung regulate, okay, regulate yung ating DC voltage from the filter, okay, to an ideal DC output. Okay? So, technically, ganyan yung power supply. So, ang focus natin is actually on the rectifier part ng ating DC power supply. Okay. I have already mentioned dito that there are actually two types of rectifier circuit. One is a half-wave rectifier. Okay. So, ito yung una nating pag-aaralan. So, let me just draw first yung ating half-wave rectifier. Okay. So, ito yung ating 220 volts AC. Okay. And then, this is actually the symbol of a transformer. Yan. And then, this is of course the diode. Normally, ang ating half-wave rectifier lang ay iisa lang yung diode dito. So, let me just use for simple explanation and understanding on your part. Let me just use muna an ideal diode. Okay, rectifier diode. And then, of course, we have here the RL, okay, which is the load resistance. Okay, so, unlike dun sa ginawa natin na DC analysis, okay, isang pasadahan lang yung ating analysis doon. Okay? Dito, when our input is already AC, okay, yung ating input is AC, then we are to consider, okay, as I have mentioned a while ago, yung ating AC, meron kang positive half cycle at saka negative half cycle. Okay? So, yan. We are going to analyze then our rectifier circuit at the positive half cycle and the negative half cycle. The analysis of it, parang ganun din dun sa DC. Yun nga lang, may dalawa tayong i-consider na cycle ng ating input voltage. Okay? But let me just give you an idea pala dito sa transformer natin. So, okay lang kung, let's say for example, alam natin yung ating voltage dito. So, let's just say this is the VI. Okay? Ito yung direct na voltage na input dun sa ating rectifier circuit. Okay? So, ito yung transformer natin. So, kung hindi natin alam yung VI dito, but then we know the number of turns. Okay? By the way, ang transformer is actually made out of winding ng coil. Okay? Ng wires. Yan. So, there are a number of turns. Let's say, for example, by the way, this is the primary winding na tinatawag natin ng transformer, yung input niya sa input side. And this is the secondary winding. So, kung let us just represent yung number of turns in the primary winding as NP, and then in the secondary winding as NS. Okay. So, yung voltage natin dito sa primary is, of course, yung 220 volts AC. And then, yung output dito is, let's say, VI. So, how do we solve for VI? Which is the voltage at the secondary terminal ng ating transformer. So, all we have to do is to use the formula NP all over NS is equal to VP all over VI or VS. So, stand for secondary voltage. So, VI, manipulating this formula, would be NS multiplied by VP all over the NP. So, yun yung formula na gagamitin natin. Okay? So, just in case alam natin yung VI, ang goal natin is to find yung output voltage, which is the voltage across our load resistor. Okay? So, ang analysis, just like what I have mentioned a while ago, we are going to start at the positive half cycle. Okay? So, at the positive half cycle, you have to listen, ang ating polarity, okay, pag makikita nyo dito, yung polarity ng ating AC voltage ay nag-reverse. Okay? It is changing. Unlike if it is DC, di ba, yung ating DC is naka-fix lang yung polarity niya. This is actually the DC voltage symbol. So, positive lang siya dyan. So, negative lang siya dito. However, dito sa ating AC ay nag-iiba siya. Okay? So, if there are several cycles, positive dito, positive, negative, and then it continues until kung ilang cycles yan. So, at the positive half cycle, when the polarity of our voltage is positive at this point, and then negative dito, okay, what is the condition of the diode? Okay, so if we are going to look at it, positive to anode, and that makes the diode forward bias. Okay, so kung forward bias siya dyan, ano ang magiging kalabasan ng ating circuit? So since ideal yan, Okay? Shorted lang siya. And then we have here your RL. Okay? And then of course, ito yung ating VI. Okay? So what is V out? So napaka-obvious, 'di ba? That our V out is equal to V out, which is the voltage across RL. That is equal to whatever your input voltage is. Okay? So that is the positive half cycle. Now, let us try to analyze din naman yung ating half-wave rectifier at the negative half cycle. Okay? This time, okay, ang ating polarity na dito ng input voltage natin is negative na dyan, and then positive na tayo dito. Okay? Yung polarity nag-reverse na siya. So, negative, okay, connected to the anode, and that makes the diode reverse bias. Okay? So, if that is reverse bias, ano ang resulting circuit natin? So, we are going to consider the ideal model. Open siya dyan. Okay? So, VI, this is our RL. So, ano yung V out na natin? Okay? V out would be, okay, since open yan, wala tayong ma-measure na V out dito. So, V out is equal to 0 volt. Okay? So, if I am going to draw, okay, yung output and input voltage together. Okay? So, let's just say this is our input voltage. Okay? So, isusuperimpose ko ha. Wala akong ibang color ng pen, but makinig na lang kayo. So, at the positive half cycle, when the diode is forward biased, V out is equal to VI. So, V out is equal to VI. Okay? So, yan. And then, at the negative half cycle, which is actually this part, okay, the V out is equal to 0. So, V out is equal to 0. Okay? So, ang output waveform natin for a half-wave rectifier is, of course, yan, at the positive, and then 0 at the negative half cycle. Okay? So, yan. So, there. Okay? So, that is how you're going to analyze half-wave rectifier. Of course, there are other details already discussed in the module. So, pakibasa na rin yung discussion doon to be able to understand better yung operation ng half-wave rectifier.